Inside this garbage incinerator steam plant in a small town in Minnesota, they burn up to 200 tons of garbage each day. If you explore the facility in detail, you'll find something that doesn't belong. A 4.5 megawatt steam turbine generator originally built for a power plant in Bermuda. It hasn't been used in years, but it used to turn garbage into electricity. Hello, I'm Jason, and this is Steam, Electricity, and Propulsion. Let's start by walking into the big room with boilers and incinerators. These big steel boxes are the incinerators, which are lined with refractory. Above our heads are the large smoke ducts that carry the heat to this O-type boiler. Inside these ducts, there is the superheater, which increases the temperature of the steam from 390 degrees to about 500 degrees Fahrenheit. To make steam, you need lots of water. These boilers can each boil 30,000 pounds per hour at 230 psi, which requires powerful pumps to supply water.
So we have two electric, then we have the turbine-driven steam water pump.
Is the turbine pump running?
I think it's in idle mode.
Oh.
This pump is electrically driven, rated at 70 horsepower, and normally runs at 1,750 RPM. Next to it is something a little more unusual, a steam turbine-driven feed water pump. Right now it's idling at about 1,300 RPM, but under load it can run up to 3,600 RPM. To pull the smoke through the scrubbers and boilers, there are induced draft fans. Today, airflow is controlled with variable frequency drive, which changes the speed of the motor using a computer. Here is how they used to control the draft on the furnace. This is the dampers and an old blower fan. To keep combustion temperatures below 1,800 degrees Fahrenheit and prevent ash clinkers from forming, the plant uses an exhaust gas recirculation system. This fan redirects a portion of the exhaust back into the incinerator. Smoke from burned garbage contains ash and other pollutants. These large structures are the bag houses, which filter fine ash from the exhaust. Above us is a duct lined with water tubes. Below it are ash hoppers.
So that flue gas is coming into the inlet of that at 1,500 degrees. You want to cool it to 1,300 before it turns.
Just beyond it is a second boiler, which receives exhaust from the second incinerator. Here, steam-powered soot blowers periodically clean ash from the boiler tubes. This boiler's drums and downcomers are outside the boiler.
That's the economizer back here.
Downstream is the economizer section, which captures the remaining heat from the exhaust to preheat the feed water entering the boiler. This system uses gas-pulsed soot blowers that produce controlled acetylene gas pulses to remove buildup from the tubes.
We put them on this economizer and we put them on the north unit south of them.
Back on the main floor, this room contains the water treatment system for makeup feed water. Activated carbon is used here to remove contaminants like mercury from the exhaust. These are the plant air compressors. Now let's move over to the garbage processing section. We start by walking through the machine shop, which includes a lathe and a drill press used for maintenance around the plant. This is where raw trash enters the facility. It travels along this conveyor, looping around the building, before being dumped into the trash pit. From there, it's fed into the incinerators. These are the trash chutes that deliver waste directly into the furnaces. Inside, the combustion temperatures reach about 1,800 degrees Fahrenheit.
Got it? We'll go look at the other one.
Here's the second incinerator.
The trash lid.
The flame appears brighter here because the trash pile has just shifted downward. Now we're heading up to the upper level of the main room. First, we'll take a look at the forced draft fans, which supply combustion air to the incinerators. From here, you can see the trash pit below, and overhead is a large grapple crane used to scoop garbage and feed it into the furnaces. This is a forced draft fan for the second incinerator. From here, we'll continue up the stairs to the top of the main room to see the deaerator. Before water enters a boiler, it needs to be heated and stripped of dissolved gases.
Do not touch this. You will burn yourself.
This deaerator operates at about 15 psi and mixes steam with incoming feed water to remove oxygen and other gases that could cause corrosion. Down below, these pumps fill the deaerator. Once the water is treated and preheated, it's sent back down to the boilers, where it's turned into steam. And in this plant, that steam once had another job. This is the steam turbine generator. When this plant generated electricity, the steam from the boilers powered this turbo generator. Today, instead of generating electricity, The plant sells steam to nearby food factories. This turbo generator was built by the British company Peter Brotherhood. It originally entered service in 1985 at a diesel combined cycle power plant in Bermuda. In that system, large diesel engines produced the main electrical power, and waste heat from the exhaust was used to generate steam. That steam, at about 150 psi, was then sent through this turbine to produce additional electricity. The turbo generator is rated at 4.5 megawatts, or roughly 6,000 horsepower. The turbine operated at 7,200 revolutions per minute and drove a 2-pole alternator at half that speed, 3,600 RPM.
There'll be a 2-pole.
The electricity produced here was controlled and distributed from this room. On this panel is a device called a synchroscope, which was used to match the generator's voltage, frequency, and phase before connecting it to the electrical grid. This big pipe carries the exhaust steam into a condenser which pulls a vacuum on the exhaust. To maintain the vacuum, here are some vacuum pumps. To condense the steam, water is pumped through the condenser by these 75 horsepower pumps. They need 2 of them under normal conditions, but the third one is for backup. Water leaving the condenser goes through these cooling towers before being pumped back to the condenser. Underneath the condenser are the condensate pumps. They pull the water out and send it to a condensate return tank, completing the steam cycle. While this turbine was designed for an industrial power plant, the steam systems behind it are closely related to those used aboard large ships. In the next video, we'll step away from this plant and look at the original construction documents from the Edmund Fitzgerald. We will see how the ship's engine room was arranged and how steam power was used at sea. If you have questions about any of the systems we have seen, you can find my email in the channel description.